folks, Mark Armitage coming to you from my microscopy laboratory, and I wanted to take a minute to thank some recent donors to the Dinosaur Soft Cell Tissue Project. As always, I appreciate all your donations and your support. Your prayers are most important, and your words of encouragement. But been pretty busy, so I wanted to take this time to thank these folks who have really been generous. And again, I have to say, this work cannot continue without you. Last week I had a couple of technicians working on both of the electron microscopes. It's very expensive to keep these things running, and they're a little bit persnickety. Sometimes they just don't want to run for whatever reason, and I do everything I can to get them back running again, but sometimes it requires a technician to come in and do the work. And so your support is really important because it helps the work continue. And so Mindy Newell, thank you so much from Colorado for your wonderful donation of $50. We appreciate it so much, and believe me, when I get to Colorado, I will let you know, and maybe we can have a cup of coffee together. An anonymous donor from the West Coast, actually a couple that are very dear friends to me, and you guys know who you are, and I thank you so much for your donation of $50. Every little bit helps, and you guys are certainly prayer warriors with this project. You're a great encouragement to me, and I thank you so much. And then all the way from Holland, Harm Kefti, you gave a wonderful donation of $100 and some words of encouragement. I'm so glad that this work is reaching all the way to Holland and affecting folks that you work with there. It's very encouraging to me, and I want to continue to be able to do this work so that we can affect people from all over the world and show them that they can trust the Bible, that Jesus is a reliable and trustworthy person to put our faith and trust in, and that we can lay down our lives, give our lives to Him, and to know that He's not only going to help us in this world with the help of His strength and His power, but also in the world to come, He's going to give us eternal life and life without pain. Boy, can I tell you about pain in my life, and many of you know the things that I've been going through. So it's a challenge, isn't it? And as you age, it's an even greater challenge. But it's not about me. It's not about, none of this is about me or anyone really. It's all about Jesus Christ, and that's who we want to uplift and give glory to as we do this work. Now, a couple of coincidences, I guess, that have happened this week with some interesting foods that people are eating and that impact microscopy, or maybe it's the other way around. Microscopy of food. And of course, we could do a whole series of studies on the microscopy of food. We, in this country, have probably the best food system in the world. But there are still some things that we need to be aware of, and one of them, the first one is, and that's why you see all these accoutrements, and here I am in gloves. I wanted to talk about the food microscopy of diatomaceous earth. Now you might say, well, what is diatomaceous earth? I've heard of that before. Maybe you're familiar of how diatomaceous earth is used in pool filters, and here I have some chunks of diatomaceous earth that I collected at the Thousand Oaks Road Cut. I don't know if you can see part of this just sort of falling away here. But diatomaceous earth is a very interesting deposit in the earth. It is the remains of countless billions of diatoms. And you can see some diatom pictures here. Some of them are staggeringly beautiful. And we're going to do a future episode just on diatoms alone. But again, here I have a chunk of this diatomaceous earth. And it's what we call very friable. It breaks apart very easily. It comes apart. And so you have to handle it delicately. But you can also see, I don't know if you can see with this camera, but there's all kinds of laminations in it. It formed with all these tiny laminations in it. But we believe that these deposits form very rapidly. In fact, if you go up to Lompoc in California, you'll see the skull of a 90-foot baleen whale that was pulled out of the diatomaceous earth deposits up there, and it was completely encased in diatomaceous earth. Scientists want us to believe that these layers built up slowly, about a centimeter per year, as these tiny little diatom bodies. They're actually made of glass. We'll talk about that more in later episodes. But these tiny little glass, silica dioxide shells settle out of the water column and form an ooze on the bottom. And yet that whale was patient enough to allow about 10 feet of diatomaceous earth, equivalent to maybe 50 million years of ooze settling out, to form around that whale skull. And so I have friends now who are eating this, and they buy it from a company called Diatomaceousearth.com, and here you can see their website. And I'm not endorsing their product, and I'm just saying maybe this is something you might want to think twice about. As a friend of mine at church, and he brought me a Ziploc bag full of this food grade, they call it food grade diatomaceous earth, and they're eating this. People are eating 2 to 3 tablespoons of this per day. And there's a couple of reasons why I think this is a bad idea. First of all, these diatomaceous earth deposits are the remains of countless billions upon billions of tiny little plants called diatoms that make their little petri dish-like home out of glass. And they're beautiful, but when they fall apart, they break apart and they break into shards of glass. And even though you're eating them and drinking them, these shards of glass are as large or larger than some of the cells in your intestinal lining, your stomach lining. And so these things can actually cut open cells just by the sharpness of the glass itself. In fact, it is recommended, if you have insects in your home, you can use this powder on the around the baseboards of your home, and just put this powder around the baseboards, and insects that are crawling there come in contact with the broken shards, the broken remains of these diatomaceous cells, and it cuts their legs open, and they end up desiccating. They dry out and they die as a result of this. So if you have a heavy roach infestation or other kinds of insects, ants that are attacking your home, put diatomaceous earth down. Make sure you crumble it up first. But anyway, I thought I would do a little experiment with this diatomaceous earth, and I've got slides here, and I've got cover slips, and I've got some water, and I just want to put a little bit of this diatomaceous earth, the food grade, on a slide. And we'll grab a little bit of this here. You don't need much, just a tiny, tiny bit is all you need. And then put a drop of water on it and moisten it. And then you just put a cover slip on it. This one got a little dirty. And you put that cover slip down, and then you examine it under the microscope. And I'm going to show you a close-up of how to do this so you'll see what's going on. And you examine that under the microscope, and you're going to see, you'll be shocked by what you see. So we're going to do a little experiment. We've got our food grade diatomaceous earth on one slide, and let's do a non-food grade. We'll crunch some of this up right on the table here. I can just turn it into powder just with my fingers, and we'll collect a little bit of this, tiny amount, it's all you need. Put that on the slide, and put a drop of water right on there. And then we're going to cover slip this also. We're going to cover slip this also. Here I have a cover slip. And we're going to cover slip this. I'll show you at a closer magnification how to do this test. And I want you to see the comparison between food grade diatomaceous earth, so-called food grade, and regular diatomaceous earth pulled right out of the ground. Okay, so what we have here is we have the food grade diatomaceous earth, and we also have a little lid full of diatomaceous earth that came right out of the ground. This is from the Thousand Oaks Highway 23 road cut, and we're going to put both of these on a slide. I decided to focus in pretty closely so you can really see what's going on here. So there's not a large field of view, but I'll try to move things into the field of view so you can see them as we go. So I'm going to reach into this bag, and excuse me for reaching across the field of view here, but I'm just going to grab a little bit of this, and I'll show you how much I have. Not very much at all. In fact, this is probably a little too much, so I'm just going to put a little bit of this on the slide and put the rest back in the sample bag. And again, this is the diatomaceous earth that is considered food grade from diatomaceousearth.com, and I'm not knocking them. I'm just naming the supplier of this in case you would like to look at their website. And when we just put a tiny bit of water on here, and you can see even a little bit of air can move this around. So I want to make sure that my diatomaceous earth is in my drop of water. And again, it doesn't take much, and I'm gonna squish this around a little bit to make sure that I don't have any big clumps under my cover glass. We don't want to have any clumps, and it seems to me all that they did with this diatomaceous earth was to just kind of pulverize it a little bit. They certainly didn't apply any heat to it, and I'm going to show you why in a second. And so now we're just going to put a cover slip down on here. Okay, and I'm just going to compress this a little bit because again I want everything broken up underneath the cover slip, and we're going to look at that under the microscope. Now I spilled a little bit of water here, so I'm going to dry this a little bit with my hand, and we'll move the other slide into place. And this now is the diatomaceous earth from the road cut, and once again we just want a tiny bit there, and I suppose I could do this in the reverse fashion. I could put down a drop of water, but I find it a little easier to go ahead and make sure that I'm actually pushing on these and breaking them up before I put the water or the cover slip on. And that's probably too much specimen there. You might say, really, that seems like so little or so much, and it's not really. That's a lot of specimen. So we'll put some water on there. And now we come in with a cover slip for this one, and we compress that down also because you see there's clumps under there. This one's a little more clumpy than the one from diatomaceousearth.com. And there you have it. There's two specimens now, and we're going to look at the first one under the microscope and show you what it looks like, and then we're going to compare it to the second one, and you yourself can make the decision as to whether or not they look any different. A friend of mine purchased this diatomaceous earth, said that it was food quality, edible diatomaceous earth, and I said, well, I'm not sure it's a good idea to eat that stuff. First of all, it has all these glass shards in it which are probably going to tear up your cells when you drink it. But second of all, I just put this in a drop of water, and look at all the bacteria swimming around in there. Now, where are these bacteria from? Well, they're not from the processing of this diatomaceous earth because it was never processed. This was never heated in a hot oven, nor was it applied to something that would kill the bacteria, like an alcohol. And so if you eat this edible, quote-unquote, diatomaceous earth, you're consuming countless billions of soil bacteria. And if you're immune compromised or you have some other digestive condition or something that might make you susceptible to some kind of disease, well, I'm just saying, it's probably not something that you want to eat. At least I wouldn't want to eat it. So there you have it, folks. A simple little test under the microscope showing that edible diatomaceous earth maybe really shouldn't be eaten at all. So this is a specimen of the road cut from Thousand Oaks, and you can see a big clump of diatomaceous earth here. I'm trying to adjust this properly. That's a diatom, that circular structure there, is actually a diatom that's within that clump. But what I really want to focus on is over here. So let's sharpen this up a little bit. And I don't know if you can see all that movement, but that is, those are bacteria. These are soil bacteria. You can see them pretty clearly. This is about as high as I can go on a light microscope. And these are soil bacteria that are part of this specimen. And so when you cut this out of the ground, you are cutting out not only all the diatoms, and you can see here they're kind of rough and they're in big clumps, but you're also reactivating with the drop of water. You are reactivating all of the soil bacteria that are part of this specimen from the road cut. And so you're really seeing what this specimen looks like in the soil. And so it's loaded with bacteria. These bacteria go back to the time when this specimen was first deposited. All of these diatoms that live in these little glass houses were alive at the time that they were buried. They didn't settle out in an ooze. They were all buried together. And so soil bacteria took advantage of the opportunity to get into the broken shells and eat the plant cells that were inside. And so what you are seeing are the revived bacteria from that event when this was buried in the ground to begin with. Now, the interesting thing about bacteria is that they are able to go into a spore container that allows them to sustain the long periods of drought where they have no water and no conditions that are good for them to revive. And so we have revived them now with a drop of water. Okay, well, here's part 2 of what I'm calling food microscopy. And again, this is very short. We could do a whole series, a whole year's worth of series on food and microscopy and how microscopy shows us. In fact, maybe you don't want to see what's in your food. But if you're like me, you enjoy eating salads. Here I have some heads of romaine that I've put in water. I like to soak these a little bit and get them all nice and turgid, nice and stiffened up, because they come in pretty lilted, don't they? They're wilted a little bit, and they don't taste as good that way. So I put them in water. I cut the ends off first so that we have a nice fresh end to work with. I cut that off, and then I put these in water and I let them soak until they get nice and turgid, nice and stiff, and then I'll separate them out piece by piece. Of course, I do recommend that you wash each individual piece carefully with running water, and then I shake the excess water off of these and I bag them all up. And the reason I'm looking in here is I see something interesting that I think needs to go under the microscope. But that's the whole point. I did this recently, and I do not buy organic. I think the risk of the pesticides, at least in my case, I'm a fairly healthy individual in most respects, and I think the risks of pesticide to me are marginalized because I do wash my fresh produce very carefully. So I do not buy organic, and so these are heads of romaine lettuce that were sprayed, obviously with pesticide, and yet I found some very interesting critters in these. Here's a picture of some of the critters that you saw. Sorry I don't have moving video, but these were dead. These were not living. And so you can see some of the examples of these organisms. And so this is why I think it's a good idea to really make sure that after you do soak your vegetables in water, wash them very carefully in running water, because you may not want to be eating these kind of critters along with your salad. Of course, some people have said, when you have ants at your outdoor picnic, they don't eat that much. They only eat a little bit. The thing is, do you want to be eating them? And so here's just a couple of examples now today of food microscopy, and hopefully we'll be able to get into more of this in greater detail as we go on. Once again, thank you for your support. I deeply appreciate your support and your prayers for my health and also for the lawsuit that's ongoing. And again, if you have any comments or questions, please send them my way. We'd love to hear from you, and we'd love to incorporate some of your ideas into some of our little shows if you would like that. Thanks a lot. God bless and have a great day.